Scientific discovery and innovation rely upon scholars to have a rich understanding of prior work. To understand a research topic, they must take time to read, extract meaning, and identify connections across many different papers. However, as scientific literature grows and becomes more interdisciplinary, it gets increasingly challenging. Consider a junior computer science researcher interested in getting a broad understanding of a research area with which she is unfamiliar. Say this topic is misinformation and fact checking. Not knowing what the important subtopics are, she starts by conducting a literature review using a common scholarly search engine and searches for the phrases misinformation and fact checking. However, even though all the papers in the search results look relevant, it is difficult for her to see the higher level themes and how individual papers relate to each other by only looking at the paper titles and search snippets. Feeling overwhelmed, she switches to Relatedly with the same query, and the system returns a list of related work paragraphs relevant to the query in the overview view. Wanting to get an overview, she skims through the section headings and quickly learns different subtopics such as fact checking and rumoring, the dilemma of fact checking datasets. The section headings allow her to skim through the overview view to get a sense of the different high level research foci. As authors often structure their related work sections into relevant subsections based on themes, these titles can help describe the gist of the paragraph's focus. As she becomes interested in the subtopic of fact-checking datasets, she starts to read the related work paragraph that has it as a section heading. She clicks some of the references to see their metadata, including title, abstract, TLDR, authors, publication year, conference it was published in, and the citation count. And she collects some of the ones she wants to read later by clicking the copy button. Noticing the current paragraph was published 4 years ago, she clicks on the Explore Similar Paragraphs button. In the Similar Paragraphs view, the system brings up other paragraphs from the search result that are also about fact-checking datasets. As she skims through the similar paragraph, she reads about how the other authors have summarized prior work about this particular subtopics across different papers. For example, AI-based fact-checking methods that rely on datasets, or datasets for misinformation detection, and datasets for fact-checking. These are extracted from different source papers. She starts to understand connections between multiple referenced papers and concepts discussed within this subtopic. She starts to feel like she's getting a more holistic and well-rounded understanding of the subtopic. She continues reading other paragraphs, including the ones that were published more recently, to more comprehensively explore this topic. She then returns to the overview view to explore other subtopics. She notices the paragraphs she is shown have changed as a result of her exploration thus far. Paragraphs have been dynamically re-ranked to prioritize ones with more unexplored and dissimilar references. She also notices that some of the paragraphs have sentences low-lighted that referenced papers corresponding to ones that she's already explored. Paragraphs also now sometimes have certain inline citations highlighted that point to unexplored references that are semantically different from the ones that she's explored before. She skips over some paragraphs with many sentences low-lighted and focuses on a paragraph with multiple different highlights. Lastly, she checks the progress bar to keep track of what proportion of the entire set of related work paragraphs and references she has explored so far. Now, to evaluate the system as an alternative approach to literature review, we conducted a within subjects user study where participants were asked to explore literature on 2 scientific topics, with the ultimate goal of producing an outline for a survey paper on each topic, using Relatedly in one condition and using a baseline system that returns a list of papers in another. We find that participants produced better quality outlines when using Relatedly versus in the baseline condition, as rated by topic experts who were blind to the conditions. System logs reveal that users of Relatedly interacted with significantly more information, both paragraphs and papers, than in the baseline condition, despite having the same amount of time for each condition and access to the same set of papers. Participants also self-reported that they prefer to explore related work sections using Relatedly than explore a list of papers to conduct literature review.